Welcome to the TPC desktop video series on using geodetics. This survey that we've opened here is called Learn Geodetics. It's available with the Geodetic Learning Guide, and in fact we're working out of a chapter called Latitude and Longitude in the Geodetic Learning Guide. Let's open up our survey information, and we find that this particular survey is using the Washington North Zone of the horizontal datum NAD 83, and we're using the WGS 84 for our vertical datum, and an elevation factor of 1,500 feet for the project. And we've set our survey up to prefer to use geodetic distance at project elevation and true bearing based on mean course convergence. Now we can override this as needed, but basically we're all set up now for the coordinate reference system to define the relationship between grid coordinates and geodetic positions. Let's go ahead and close this out. Let's start by taking a look at the point view. I'm going to open the point view and pin it. Initially, in this view, we're displaying northing, easting, and elevation, the grid coordinates for these points. However, I'm going to open up the Point Manager Format dialog box and replace those coordinates with latitude, longitude, grid factor, and convergence. Let's use lowercase y, x, s, and w. I'm also going to put in the status as well. Notice that the point view now displays latitude and longitude as well as the grid factor and convergence. So Traverse PC is working with geodetic positions all the time that it's working with grid coordinates, and it's just as comfortable working with geodetic positions as it is grid coordinates. Now, the grid factor and convergence that are computed here for each point are part of what relates the geodetic position to the grid coordinate based on the coordinate reference system that we've selected. In this case, NAD 83, continental United States, the Washington North Zone, and WGS 84. Let's go ahead and open up the traverse for the east-west true bearing. Traverse PC displays that traverse for us. I want you to notice that this traverse is displaying geodetic data. So I've got latitude and a longitude here. You might notice that the latitudes are all the same, so I'm really running an east-west line here. And I created that line by entering the starting geodetic position for 201, and then each course is a geodetic distance and a true bearing, in this case due west. If I were to pull down the view menu and choose display raw data, I can actually see the data that I entered and that Traverse PC is using to compute the geodetic positions. So here's my starting latitude and longitude, and here are my true bearing and geodetic distance that I entered for each course. If I turn off display raw data, now I can see that the rest of the screen is filled in here for me. So let's come back to the Point Manager, and I want you to notice that in the status column there's a G for points 201 through 206, the same points that are in my true east-west bearing traverse. The G indicates that these points prefer or have preference for the geodetic position over the grid coordinates. So if I were to recompute these points, or if I were to go in and change the coordinate reference system, Traverse PC would start with the geodetic positions and it would derive from those the grid coordinates. So every point in Traverse PC either has a grid coordinate from which it will derive a geodetic position, or it has a geodetic position from which it will derive a grid coordinate. And it depends on which one you entered and which one you computed. In this particular traverse, we started by entering the latitude and longitude for point 201, and we computed geodetic positions because of the geodetic distance and true bearing direction types that we chose for this traverse. So let's talk about how we enter a latitude and a longitude. I'm going to come over to the latitude in this traverse view, and I'm going to press the space bar. The space bar allows me to edit the existing value. the same way I would if I had typed it in. So I see that I enter 48 degrees, 5 minutes, 48.881 seconds. A positive value is in the northern hemisphere and negative values in the southern hemisphere. So 1 decimal place between the degrees, the minutes, seconds, and as many decimal places of seconds as you want to enter. When I press enter, Traverse PC converts that to 480548 881 north. I also could have started by entering an N in that column. So instead of a plus, I could have entered an N, 48, and I would have gotten the same value. Now let's take a look at the longitude. Let's do the same thing. I'm going to press the space bar to edit what's here, and Traverse PC displays it as a negative 117. So I enter west longitudes as negative, east longitudes as positive. I could also enter a W 117 if I wanted. Okay, let's do that again. So I'm going to put the W in here, and Traverse PC would record it as a west. We use the plus and minus for the latitude and longitude so that I can enter the appropriate direction from a numeric keypad. I don't have to reach over and type the N or the W on the QWERTY keyboard. And of course, once I've entered that latitude and longitude, Traverse PC records that as my preferred position for this point over the grid coordinates. And so that's why when I went to display raw data with the Shift F9, I see that I've got a latitude and longitude there that it's holding for me as if it's raw data, along with the true bearings and geodetic distances. And if I come back to the point manager, that's why I have the G in the status column. You may not have to pay too much particular attention to whether a point is preferring the grid coordinates or the geodetic position. Most of the time it'll just track right along with you as you're entering the data. Let's take a look now at formatting the traverse view for geodetic positions. We've got latitude and longitude displayed here. Let's go into the traverse view format, click on the Format tab. You can see that I used the same letters that I used in the Point Manager, Y, X, W, and I'm going to put an S in here for the scale factor. Let's come over though now and also include a northing and easting in the display sequence. And when we choose OK, Traverse PC expands the traverse view to show us all the information we've asked for. So we've asked for northing, easting, elevation. We've asked for latitude, longitude, grid factor, and convergence. So really any of the information about this point, whether it's grid coordinates or geodetic positions, can be displayed at any time, both in the traverse view and in the point manager. We generally like to keep the columns limited to the ones we're working with in the traverse view, and you're welcome then to go back to the point manager and display the geodetic information along with the coordinates. Finally, in this video, let's take a look at importing and exporting geodetic positions. I'm going to come up to the desktop and choose File, Export. Let's go ahead and choose an ASCII coordinate file because it supports geodetics. I'm going to click on this little ellipse box next to the type, and I see that I can format my export data quite similarly to the way that I did the point manager in the traverse view, except in this case I use an uppercase T for latitude and an uppercase G for longitude. Let's tell Traverse PC that that's the information we want to export. Let's go ahead and export that data, and then let's preview it and take a look at it in Notepad. And I can see that for each point, in addition to the northing, easting, and elevation, I've also exported the latitude and the longitude using N for north and W for west, just like we did when we entered the data, or could have entered the data, in the traverse view. So let's come close this out now and open our traverse back up. And let's just recap real quickly that I can display geodetic or grid coordinate information in the point manager. I can display geodetic or grid coordinates in the traverse view, and I can both import and export geodetic positions just like I can import and export grid coordinates.